All right, this is the first example of chapter 7.2. It is question 135. Let's read the question. Light of wavelength 550 nanometer passes through a slit of width 2 micrometer and produces a diffraction pattern. Part A, find the location of the first two minimum in terms of the angle from the central maximum. Now, because we did these type of calculation in section 7.1, I'm not going to do it here. I'm only going to solve a part B, but we need the answer from part A in order to solve part B. So I wrote them down here. So the angle of the first minimum is 16 degree. The angle of the second minimum is 33.4. I also read in the two other relevant piece of information, which is lambda 550 nanometer and the width, which is 2 micrometer. Now, part B state, determine the intensity relative to the central maximum at a point halfway between these two minimum. Well, a point halfway is basically you take the two angle, add them up, and divide by 2. We get 24.7 degree. Now, in order to find the intensity, we first need to find the value beta. And we need to use this formula over here. So beta is equal to pi, multiplied by the width, multiplied by sine of the angle, theta b is the angle I calculated over here. So the 24.7 degree divided by lambda. All right? This will give us 4.77 radiant. Now, in the next formula, we will again need to use sine, but if your calculator is set in degree, make sure you do the conversion. My calculator is set in degree, so I'm gonna convert the 4.77 into degree by multiplying by 180 divided by pi, and it gives me 273.3 degree. All right? I will need to erase that part. So pause the video if you need to, write down the relevant piece of information, and I will continue with the next part in an instant. We will need the angle and this side. So beta 273.3 degree. We need to use this formula. Intensity is equal to the intensity of the central maximum, sine of beta divided by beta and square of this answer. All right. Now, most of the time, we are asked to find a ratio between the intensity of the central maximum. Now, by the way, this intensity is always the highest one, and it makes sense. The ray converge in the middle point. That's where most of them will go, so the intensity will be higher. And this is the intensity at a given angle. In this case, it's at the angle halfway through between these two, so 24.7 degree. Once we input all the value we have, we find that the ratio is 0.044. Now again, it's a ratio. It does not have any unit. All right. So the logic remained basically the same when it comes to dealing with single slit interference and talking about the intensity in this case. The logic is the same, just we use a different formula, and it's a two-step formula. We first need to find beta, then we use this one in order to find the intensity. So nothing really new here. All right. So see you in the next video for the last example on this section. All right. See you there.